right, so here we go. We're back again for another type of data structure. Okay, data structures. Yeah, we've seen one data structure already. It's called a list. Okay, I've also called it a collection, which it is. It's a data structure as a collection. And what can you do with a list? Well, you can store a whole bunch of values into it. Okay, but there's more than just lists in the world of Python, because sometimes you want data structure where you're going to store a bunch of data in, sometimes in different formats, sometimes in different speeds, sometimes for doing different things. And in today's lecture, we're going to cover two of them, which sounds like a lot, but in reality, tuples is hardly going to take any time to cover, and sets is also doesn't really take a long time because, I'll be honest, we don't use them a whole lot. But if you ask me when was the last time you used a set in Python, I would have to say like an hour ago. And I'll show you the problem that I was actually trying to solve, because I think it's kind of like an important thing to see why would somebody actually use one of these. All right, so as usual, I will probably do a lot of this stuff on the side. There's no official textbook, or sorry, in the book that we're using, the OpenStax one, there's nothing there, but if you take a look in D2L under Appendix G, you'll find some stuff about sets and tuples. It's something I had to put together. All right, so let's put this over here, and I'm just going to start to put some things together over here in the interpreter so we can run it and we can mess around with some tuples. Okay, here we go. Color. Well, colors. Well, actually, for those who carry on and do any more IT work, one thing that's really, really important is the way how computers display colors is they always take three primary colors and mix them together. It's a red, a green, and a blue. So everything that you see, for example, if you look at this green button, basically the green is on pretty much full, but the blue and the red are basically turned off. If you want white, you basically turn them all on. And if you ever do a little bit of reading about how computer monitors work, you'll realize that there's a little tiny pixel in each, there's a bunch of little tiny squares called pixels, and basically what you're looking at is just a bunch of different colors, and the colors are always formed of three values: red, blue, and green. Now, you don't need to know that for this, because all I'm going to do is I'm going to make a data structure. Okay, so here we go. 255, 180, and 30. There you go. So what this is a color variable that actually has three parts to it. Okay, pretty straight. And the square brackets tell me it is what type? It's a list. Yeah, that's exactly it. So if I simply say type color and I run this in a different language, here we go, and let that run. Here you go. So yes, it happens to be a list, and yeah, we've been learning about all these different functions, about adding things, picking things out, iterating through, and so on. That's perfectly fine. What I need to cover today is a brand new, different type of data structure. Okay, ready for this? Okay, watch this one, because this is going to be absolutely amazing what I'm about to do here. I just put parentheses and says square brackets. Yes, okay. That's a different type of object. So let's clear the output. When I run this, it's not going to tell me a list, but it's going to tell me that it's something called a tuple instead. Okay. Looks pretty much like a list, isn't it? Yeah, it really does look like a list. The only difference is it's round brackets as square brackets. But to make things even a little bit more weird, if you do this, it means exactly the same thing, okay? Because you might look at that and go, well, that's a mistake. But no, that's actually a tuple. Okay, the parentheses are optional, but I usually say leave them in because it makes it a lot more clear. Okay, so you'll always see me put them in. All right, so that's great. So we got this thing called a tuple. Great. So what? The question would be, what can we do with it, and what does it look like? And so obviously it looks kind of like this. We know it's a tuple. All right, I suppose the first thing is, what does it look like if I just try printing it? That's not a big surprise. It just looks like a tuple with the parentheses. Oh, sorry, a list with parentheses rather than square brackets. And yes, even if I remove those parentheses on line number 1, it would still print exactly the same. So when it gets printed, it puts the parentheses. Okay, big deal. But you notice it looks an awful lot like a list. Okay, and yeah, I mean, that's exactly what it is. It looks just like a list, except that it's got different It's got different brackets around it. Okay, so in that case, well, there must be a difference because obviously I'm not going to come in and say, hey, there's another, you can spell it as LIST or TUPLES. Okay, no, there obviously is some difference. All right, let's see if we can spot some differences. So what can we do with a list? The first thing that we can do with a list is we can go in and we can pick out individual elements. Like, for example, if I wanted the very first element and that was a list, how would I print the very first element, only the first element? Yeah, I would say color. Spell it correctly. Yeah, what bracket? Okay, I think I couldn't quite hear, but I saw this. So I assume that you mean this one here. Okay, and all right, so run it, and yeah, that's exactly it. So it's still the same subscript operator as before. The square brackets are used to pull it out. Okay, so no difference. Oh, okay. What else can we do? Okay, here, let me print a horizontal line. All right, what else could we do? Oh, we could iterate through for X in color. Remember, I always start off with X first, and then I will give it a name in a few seconds. Print X. Remember, we could do this with a list, and we could iterate through them. Can we do the same with the tuple? And the answer is yes. Okay, and what would I call this? Well, really, this would be like a component in color. You come up with a name that makes sense, and these are called like color components. All right, but if we want it to be really, really cheap, yeah, we could probably use C. Okay, maybe it's at least a little bit closer rather than X. All right, so, oh, exactly the same. All right, well, obviously there's going to be some other differences. Okay, we have to keep going to see what else we've got. Okay, let's print another horizontal line. Okay, print C. Now, we were talking about square brackets, so what if I said 1:3? Okay, that would mean, now if it was a list, this would be list slicing. Okay, and if that was a list, what would we expect to see? So here, we'll change it to a list for a second so there's absolutely no confusion. All right, if this is my program, what would I see when I ask for C 1:3? 180 and 30, and of course it would include position number 1, position number 2, but it would not include position number 3. All right, and if you run it right now,
there's no number.
Oh, not C, sorry. It's called color. Sorry, that was not meant to be a trick question. Okay. All right, so that's exactly it. And what happens if we go back and instead of using it as a list, we turn it into a tuple? Well, it works exactly the same. The only difference is when you ask for the slice, you get a tuple. So essentially it's tuple slicing? Yeah, I guess that's a reasonable way to put it. Oh, so in other words, it's exactly the same thing. No, okay. We're still on a hunt here to find how things are going to be different. Okay, let me clean up these ones and let's try a few extras then. Okay, let's try this. How about min of color? What do you think? What are you expecting? Expecting 30, and that's exactly it. Oh, okay, so min works. Guess what else works? Yeah, of course, max is going to work. What are we expecting? Yeah, of course. And sum? Okay, well, it's going to be 255 plus 180 plus 30, so whatever that is, okay, fine. Okay, you're not expected to be able to pull out that in your head. Oh, so again, we're not too much different. Okay, oh, sorry, here's another one. LEN? Yeah, 3, because there's 3 elements inside the tuple. Oh, yeah, so in other words, the tuples are just lists. Okay, well, almost. Obviously, the one thing that you can do is you can avoid putting these things in place. So, hey, look at that. You're saving typing a couple of characters. Everything still works the same way. Put them in so it's very clear it's a tuple, by the way. Okay, just put them in. It's not worth saving anything. So now the question then becomes is, well, fine, if this is the case, then what's the whole point of this thing? Okay, the whole point of this thing. Okay, so let's start doing some things that are going to cause me some trouble. Okay, color at 0 is equal to 200 print color. Okay, if this was a list, okay, in fact, I'm going to make it a list for a second. There, we'll put it here, make it a list, because this is what we've seen before. When I print color, what am I going to see? 200, 180, and 30. Okay, exactly, because you can go and you can modify the individual items. All right, here we go. Let's turn this into a tuple, because, I mean, everything else has been working, but when you try to do this, yeah, it gives you an error, and it says that Tuple object does not support item assignment. Okay, here's the rule on a tuple. You can't change it. Okay, basically, a way how to describe this is it's a read-only list. Yeah, so once you create the tuple, you can't change it. Okay, that's all. So what's the point? Oh, but otherwise, it's exactly the same as a list. You can iterate through it. It's an ordered list, so you are guaranteed anytime you go through it, you're always going to get everything in the same order. You can do the count. You can do any of the read type operations, but you can't modify anything. For example, you can't do this, and you wouldn't be able to do something like dot append. Okay, because that's just not going to exist at all. It just says it has no attribute called append because it doesn't actually support one. You won't be able to do an insert. You won't be able to do a delete. You won't be able to do a pop. Okay, all these operations that change things, yeah, you're not going to have access to. Sorry? How could you sort it? Because sorting would mean you're changing it. Yeah, so again, no, you can't do that. Okay, so pretty limited use. So why do you have things as read-only? Okay, well, I suppose we put it into a context of something everybody will understand. Okay, back in the early days, the very first bank account that I ever had, okay, I had really long time ago. It was probably about 7 or 8 at the time. And I remember being really amazed by going to the bank, giving them the little book. I don't know if you guys have ever had one of these. And I gave the teller some money, and they wrote in the book $50. And I got home and I said, how come I can't just put a 1 in front of it and say I just put in 150? You see, that's a case where you can actually modify something. But you see, now that everybody's using online banking, can you just go in and change things? And the answer is no. That's a purpose of read-only. Obviously, somebody has to be able to change it, but definitely not the end user. This is often what we end up using tuples for. You see what if I've got, I think I have some examples of this coming up. Okay, but we'll wait because I've got a couple of extra things. I will keep it in the same order as the slides this time. Okay, so here we go. Let's build up a tuple then of things that we can't change. What type of things can we can't change? All right, here we go. You can't change this. Okay, you can make a joke about that you can't change students. All right, but in any case, here we go. Let's just take a bunch of information about a student. So I'll use the exact example that I have here. Okay, we would probably have to take a guess about what each of these pieces of information means. Okay, for example, student at position 0 is probably name. Okay, student at position 1 is an ID because it looks like our IDs, and student at position 2 GPA. Looks like a GPA. All right, should we be able to just go ahead and modify the GPA of a student? Well, not through some kind of a process. So, hey, maybe we've got something that would maybe have a reason why we want to have a tuple instead of a list. Okay, I have to show you something very important because sometimes you get back tuples from various systems. And unfortunately, we don't have anything to deal with, or I don't have any example of this at the moment, but this will come. I'd like to just not show it, but we're going to need it in a little while. Okay, but here we go. Let's suppose I wanted to extract those into variables that made a lot more sense. Because right now, if I wanted to print out the name of the student, I mean, take a look at this. I would have to say student at 0. Then you'd have to print out student at 1, and then print student at 2. Now, this is fine because everybody can understand it, but imagine, remember, programs are not meant for little tiny things. We're talking really big exercises. And if you were to run across a piece of code that looks like this, so sorry for the really long, okay, we'll clean that up in a second. If you ran across a piece of code like this, do you know what's being printed? And the answer is no, not really. Okay, we're going to solve that using something called a dictionary later, but this is a bit of a nasty problem. So in order to make these print statements just look a little bit better, I'm going to use some variables. Okay, and here we go. I'm going to have, well, a name variable, and I'm going to go to take that from student 0. The next one up, somebody said it was the ID number. We better use SID because ID is used by something else. This would be student at 1. And GPA, student at 2. You see, now what I can do, instead of having to refer to those individual items, instead what I can talk about is I can talk about the name. I can talk about the student ID, and maybe even student underscore ID would be better, and I could talk about GPA. And again, if you ever found in a big piece of code, print name, print SID, and print GPA, that is a lot more sensible than print student position 0, print student position 1. All right, so this type of thing happens all the time, so yeah, it's not a big surprise. So quite often what we have is we have data that's in a tuple, and what we want to do is we want to turn it into variables. All right, great. I mean, it's pretty easy. It's 3 lines. Well, you know, like everything else, I've said it before, programmers are often very lazy. And what they've done is they've provided a small feature that allows you to prevent the poor programmer from having to press the enter key so many times. That's about the best way I can describe it. So let me show you the kind of cool thing. All right, remember, a tuple is actually defined by the commas, not by the parentheses. Okay, so it's by the commas, not by the parentheses. So here's what I'm going to do, SID and GPA. All right, I'm going to put the parentheses in anyway. Okay, and I'm going to start asking, what type of thing is student?
A list.
No, it's not a list. It's a tuple, very good. And parentheses name SID GPA, that is also a tuple. And guess what? You can take one tuple and assign it to another tuple. And what this ends up doing is it takes the individual items and it puts it into the individual variables. It's really kind of a cool little thing. So here, let's clear the screen. It basically allows you to do this big long assignment on a single line rather than breaking it across multiple. Okay, useful if you have tuples, yes. There's going to be a couple of cases where this becomes really, really critical. Okay, it's not something that we use a whole lot of times, but this is, but when you need it, it's really, really good that you have it. Okay, the topic is called tuple unpacking. Okay, so let's get over here, make sure I haven't missed anything in the slide. So we get a couple coming up. So here's the example with the colors. You can use the indexes and so on. Tuples are like lists, but immutable, which means that you can't change them. There's one of the side effects. You can always make a brand new tuple. We'll talk about that. Tuples are defined using commas, but almost always include the parentheses as well. There's only one thing that's incredibly, incredibly strange, and I better warn you about this right now, because this will almost always happen. Okay, so this is like one of these really weird things. I've been burned by this myself a whole pile of times. The solution looks a little weird, but when you think about how you define tuples, it makes a lot of sense. All right, here we go. So I'm just going to call it values, just generic term right now, okay? Okay, print type value, print values. Oh, sorry, let's call it values. All right, my question is, what type is values? Not a trick question. It's a tuple. It's a tuple with 2 things. Okay, very good. Now it's a tuple with 3 things. Okay, yeah, very good. Okay, good. And obviously I can add some more. And now I've got I got an integer. Yeah, surprise. That's not a tuple. The parentheses just mean regular parentheses for arithmetic. Watch out for this. This can be really surprising. If you really want to have a tuple with 1 value, you've got to do something incredibly weird. You have to put a comma at the end.
Okay.
Because remember, commas are what defines the tuples, and that is a tuple with 1 element. It's the one outlier, okay, one of the outliers. Okay, just watch out. If you ever need a tuple with 1 parameter, you need the comma at the end. It's really, really strange, but you need it, yeah.
Why would we need a tuple with 1 integer?
Okay. In order to explain that, I would have to show you some other code. Okay. I was eventually going to show you some code, but you know what? I might as well, because it's legit. I mean, it's one thing to say, yeah, well, there's these things called tuples, but then never actually show any code. Give me a second, because I would be using one of these. There we go. All right. Don't be freaked out by anything you see. There's a lot of stuff in here. After you have filled the entire course, okay, and you've taken the database course, you'll be able to understand the function I'm about to show you. Okay, but we'll look just at the important thing. So here's a piece of code.
Okay.
Okay, and what this is doing, this is getting a list of courses out of D2L for a certain semester. Okay, and just because I'm interested just in a couple of things. Oh, hey, since we're here, look what I'm doing. I've got a result and I made it equal to an empty list. All right, I put myself into a for loop and I kept calling append. I told you it's a programming pattern you see all the time. Yeah, it really is. All right, does anybody see the tuple and which line number? Hey, that could be like a multi-choice question on the midterm. It's like, which line has a tuple on it? Is it 47? No, not 47. 45. 45 is the tuple. Okay, you see? I even included the parentheses. Okay, and there's the comma. There's a single element tuple. Why do I only need, or why would I have a tuple with a single element? Because my select statement required one parameter to be passed in. That's why I have it. And this particular function for running MySQL database queries, it takes tuples for the parameters. Okay, that's why I had to include it. Okay, toss this away. We'll bring this one back later because I can show you some other cool things that I did with it that's also related to the day's work. All right, that's a bit weird. Okay, so if that's a bit weird, we better go down and even one step further because 10 is no problem, 2 is no problem, 5 is no problem, but 1 was a problem. Therefore, what is that? Kind of looks like a tuple with nothing. Okay, I mean, a square bracket, open square bracket, that's fine. What happens if I run this? I mean, is that a tuple? Yes, it is. Yeah, so they didn't require, they didn't require commas. All right, that's one way of spelling an empty tuple. To be honest, the other way that I usually spell it is to spell it this way. Okay, and I do this just to remind myself that it really is a tuple. Yeah. Okay, it's a read-only version of a list. Okay, so we haven't seen a reason why we need it yet. Okay, but it's basically a list that you can guarantee that nobody's going to modify. Okay, and I know that there's an example coming. Okay, so there we go. Back to tuples and read-only. Okay, let me see what's coming. Okay, so here we go. So tuple unpacking, that's where you take a tuple and you unpack it into individual things. We will be doing that later when we hit dictionaries, so we do need this one. And of course, now the question is, why do we have them? Okay, when you have data that shouldn't be changed by a function or another part of a program, okay, we're gonna have to make one of those. Okay, so we'll actually make one before we go to the next page. Or it can also be used for returning values or multiple values from a function. That's actually one of the reasons why we quite often use it. So I've got examples coming up. And some libraries actually require, for example, the MySQL stuff that I use actually requires that you have to use tuples. So you have no choice because somebody else has decided you must use them. And I suppose that's kind of true for tuples in infs1201. The only reason why you're going to use it is because I told you to. And that's true. I mean, you're not going to voluntarily say, hey, let's use a tuple. Do you think I make tuples all the time? No. I use them when I'm told I have to because I'm calling a library that needs them. Because unfortunately with the tuple is you can't modify it and sometimes you need to. Okay, so again, you use it because somebody told you you had to. But I think we can probably make up a small example for dealing with the tuple and why we might use it. Okay, let's write a function. Compute average. Ooh, here we go. Compute average, we're gonna have a bunch of scores, okay, and we're gonna go through and we're going to calculate the average. Now, I know very well we can just use a sum and account. A sum and account, do the division, it'll be fine. Let me do it the slightly harder way for a second, okay, just because I don't really need a loop, but, oh, you know what, let's do it anyway. Okay, here we go. Let's get this. So the average, how do you calculate the average? Okay, quite simple. You take the sum of the scores and you divide by the the length of the scores, wrong language, by the length of the scores. Okay, that's the average. Oh, don't forget to return the average. Okay. Okay, you get an 80, you get a 90, you get 120, a 45, a -2, and a 10. Those were the scores on the midterms. Okay, somebody's done incredibly well. Maybe there's a bonus. Who scored the -2? You hope that I'm not going to apply. Okay, how could you possibly get a -2 on a midterm? Okay, some psychotic people will set up rules on MCQ questions that if you get the answer correct, you get like 3 points, but if you get it wrong, you get -1. It's to prevent people from guessing. Okay, don't worry, we don't do this here. Okay, if you get it wrong, we just give you a 0. But I've seen lots of cases where this is done. So I suppose it's possible somebody could get a negative score. Ooh, that would mean you'd want to really make sure you know the answer before you pick something. All right, and let's do this. Let's calculate the average, compute average, and we'll pass in the midterm tests, and we'll print out the AVG, and we'll look at it. Okay, that could be, I don't know. Okay, all right, but that's perfectly fine. All right, yeah, it has nothing to do with tuples whatsoever. Okay, here's what I want to do. I would like to modify my function a little tiny bit, because you never know who wrote the function. Maybe it was somebody very, very generous who says, you know what, I don't like these negative values. So what I'm going to do is I'm going to go through all of the items. So I'm going to say for index in range, length of scores, and I'm going to say if scores at index is less than 0, I'm going to say scores at index is equal to, 40, just because I'm feeling better. Okay? All right. Now, obviously, this is going to give me a different average, right? Because obviously I'm doing this. But remember, the issue is, if I were to print the midterm tests afterwards, remember the midterm tests change, because whenever you pass in a list as a parameter, the function can actually modify the values. Okay, that's one of the things. All right, so there you go. So that's a side effect. It's something we're not supposed to do, and you say, well, it's just don't do that. Remember, code is not 12 lines of. Is not a 12-line program. A real system probably has a couple 100,000 lines of code, and you are calling functions that other people have written. And maybe you don't understand what their function does. Okay, so in other words, it's a little risky. Okay, but watch this. Instead of using a list, what if I pass in exactly the same information as a tuple? Okay, now when I do this and I try running this, yeah, it actually crashes, because think about this. When the tuple gets passed in as scores, and by the way, it works exactly the same, there's no errors here, other than the fact that somebody tried to change it. That was the only error. And because tuples don't support item assignments, my data is safe. The original is not going to be modified. There's a good reason to use it. So if you're calling a function and you don't trust the person who wrote the function, you can always turn it into a tuple. Oh, but what if I have a list? I mean, what if somebody has a list of scores because we asked the user to enter a bunch of lists of scores? Okay, it turns out it's really easy to turn a list into a tuple. Okay, all that you need to do is you use the word tuple, like what we've been doing with int and float. Yeah, it's just tuple, pass in the variable. It will take a list and turn it into an exact copy with all the same values, but in the form of a tuple. If you try to run this version of the program, sorry, clear the output, yeah, that also ends up crashing. So this is what we might use a tuple for, is just to guarantee that when we hand it to somebody else, they don't mess with it. Yeah. On line number 4, well, this is the trouble, because maybe the person who wrote this function said, well, you know what, I feel really bad for the students who got less than 0, so I'm just going to round up their grade to 40. Okay, yeah, we shouldn't be doing this, but sometimes people make mistakes in their code, and it's not always this obvious. It changes whatever, well, it made an attempt to change the score at a certain location to be 40. If I put it back as a list, not as a tuple, okay, you see what's happened is the score that used to be -2, this one right here, is suddenly changed to a 40. But because that function shouldn't be doing that, if I pass it in as a tuple, at least I can guarantee that nobody's going to mess with it. Okay, so it's kind of protection. It's to protect your data against accidental modification. Okay, so useful depending on who wrote the other function. If it's you who's writing it, okay, well, don't mess up. Well, that's easy to say, right? Don't make mistakes and everything will be fine. That's a really good motto in life. It's really hard to pull off at times, but this is the thing. You just have no idea what the function is going to do, especially if somebody else does it, but you pass it as a tuple, you're guaranteed it will not be changed. There you go. There's one reason why we might use a tuple. All right, we have to come up with a second one. Okay, perfect. I've got a function. I'm just going to reuse the same function that I've got. Okay, I got a bunch of data, and I want to find out which one's the biggest. Okay, yeah, we've been through this before. Okay, largest is equal to max of data. Well, that's pretty simple. Return largest. Now, I'm obviously going to make some changes to things. So here we go. Test scores. Actually, it's temperature readings here, but that's fine. 40, 45, 38, 56, 20, and 18. Okay. That could be midterm scores in this course. Whoops. No, I hope it's better than this. All right, so which is the biggest, what's the biggest test score? 56, okay. Okay, we'll call it big, just so I've got a different name. I'll call the function largest value, and I'm gonna pass in the test scores, and I'm going to print big, and yeah, it better say 56, and that's exactly what it is, okay? Yeah, I could have just used max directly. Here's the thing. I wanted to make the function just do something a little bit different. Okay, so let me write the comment in the form of a docstring. There you go. Not only do I want this function to return the largest value, I also want to know which position in the array was the largest. Okay. So what's the position of the biggest value? So you said it was 56. Well, the position is 0, 1, 2, 3. It's in position number 3. Okay. Now, can we do this, or can we do this type of thing? Yeah, the location. I mean, we've got lots of built-in functions for lists. One of the things is if you take your data, there's an operation called index, and this will tell you the location of something. And if I simply ask for the location of the largest, and I'm just going to print it for right now, location, 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 location. There you go, location 3. That's the right value. Okay, so we had the biggest, we have the location, but the thing is, what have I been telling you about functions? How many things can you return? One thing only. But I want to send back both. Okay, yeah, you can send back both things, but what you do is you send it back as a tuple. Now I'm sending back 2 things. Right? Take a look at this. When I run this, see what I get back for big? Big is now 56 and 3. Oh yeah, the first one is the largest value, the second one is the location of the largest value. And now I could obviously print out some kind of a message. Like for example, the highest score was, okay, we'll call it big 0 in, sorry, I'm gonna have to continue on, so let me hit plus. I think I can do this one, plus another F here because we're still going in position big 1. There you go. The highest score is 56 in position number 3. Yeah.
What is the type of big?
Ooh, what's the, okay.
What's what?
Thank you. Nice question. Okay. All right. Well, I'm not going to answer that. Somebody else is going to answer that. What are we getting back? Take a look at the return on line 8. What am I returning? Yeah, it's a tuple because of the comma. Yeah. This is a case where I didn't put the parentheses, but I could certainly do it. And that is going to be a tuple. So that is actually a tuple, and that's why I can pull out the individual things. Now, did I really need a tuple? Could have I returned a list instead? Yeah, I could have. Okay, it's just I don't know, really, they didn't need tuples here other than just to deal with it read-only. But most of the time, if you want to return multiple things, like 2 different values, 3 different values, quite often what you'll end up doing is you'll return them as a tuple. Lists usually signify that you have like the same piece or the same type of data that's repeated a bunch of times. It really wouldn't be appropriate to return it as a list. You could technically do it, but because you have something that's kind of completely unrelated to each other, it probably makes more sense to be formed as a tuple. Oh, and since we're here, instead of storing it as a tuple directly, how about we put it this way? Highest and location. Remember, we're allowed to do this. We're allowed to have a tuple is equal to a tuple on the right-hand side. Because now what I can do, instead of having big at position 0, I can say highest. And instead of having to say big at position 1, I can say location. It's exactly, I'm sorry, and, oh, I don't have big anymore, so sorry, I can't print it. There we go. There we go. So that can make the program just a little bit easier to read. So largest value returns 2 things, the highest and the location. And it's the same example that I've got here. Okay, so let's go back and hit a couple of these. Okay, 38. I think I might have to step up the pace a little bit. Okay, here we go. So there was the first one about using a tuple and guaranteeing that the midterm grades weren't changed. Here's the example of returning 2 things. It's almost the same idea. Return largest and location. Had to do with temperatures rather than scores. All right, the final thing is, yeah, there's a lot of built-in libraries where you just have to use it. We don't use the built-in libraries here, but I figured I better include it, and you saw a case where I ended up having to use it. I just picked something very, very simple in here, but I can't even run this on our interpreter. So don't worry about this one. Okay, tuple concatenation. Okay, can you build up larger tuples? And the answer is yes, you can. Okay, so if you have a tuple called T1, whatever that means, 1, 2, 3, you have a tuple called T2, which is, there we go, to something that's different. And if you said T is equal to T1 plus T2, and you print T, yeah, if you take 2 tuples and add them together, you get yourself another tuple with all the values. Okay, there you go. So not a big deal on this one. That's exactly the example that was given here. The only thing that I've kind of done a little bit weird is I'm saying scores, which is a tuple, is equal to scores plus the value. And I'm building up a tuple this way. So if you wanted to ask the user to enter like 5 scores and put them into a tuple, you could do this. Would I really use this? No, I'd probably use it as a list instead. Okay. All right, so there we go. There's the stuff about tuples. It's like a list, only you can't change it. Okay, that's really it. When you use them when I tell you to. And the good news is I always tell you when I want them used in 1201. So sometimes it will be write a function that takes a tuple and does something with it. Write a function that takes a bunch of parameters, does a bunch of stuff, and returns a tuple of a bunch of different values. Okay, that's the other place where I use it. You would never be, I don't think you would ever be given the question of, okay, design a function, you figure out whether or not it's a tuple or a list. Usually I wouldn't do that type of thing. I might ask you, why would you use a tuple instead of a list? Okay, well, that's fine, so read-only versus read-write. But it's not going to be a case where you have to make a decision about which one to use. You'll be told when to use them. But generally, if you just have a bunch of values, all the same type, and you want to be able to store them in an index format, a list is probably a lot easier. Okay, in any case, here we go. Out of the way. Okay. In for something new. Okay. I realized this morning, well, actually just a little while ago, that there's some pictures missing from the slide, so sorry about that. Let's see if I can bring up a small picture just to maybe bring up some horrible memories of things. Here you go. All right. What I've got over here is I've got something called a Venn diagram. Don't worry, we're not going to be asked questions. Well, actually, we'll be asked questions about this. All right, this is called a Venn diagram. You probably remember from math. Okay, and usually what you use Venn diagrams with is when you're talking about sets of information. Okay, sets is yet the second data structure that we'll be using in this course, or sorry, another one, because we got another one. It's the second one for the day. And what do you use a set for? Okay, well, we have different reasons about why we want to use sets. Okay, so here we go. Let's, I'll use exactly the examples that I've got here. Okay, here we go. First one up. Okay, not a trick question. If I run this, what type is colors? What type is it? It's a list because of the square brackets. Okay, all right. If I remove the square brackets, it becomes a tuple, or if I include the round brackets itself, it becomes a tuple. All right, now we've got something new today. All right, because there's all kinds of different symbols on this keyboard, and this one right here, the curly braces, well, there you go. There's another way how to enclose things. All right, when you run this, you get something called a set. Okay, so fine, what's a set? Okay, you know what, the best thing to do is, we'll have to make a few sets to see how things look. All right, first one up is, let me print colors. Okay, here we go. Print colors. Okay, what do you think? Okay, the difference between a list and a set, okay, instead of being square brackets, it's curly braces. Okay, and obviously a tuple is parentheses, that's fine. Did you notice something else kind of a bit strange that just happened when I printed it? Yeah, the order. There is absolutely no sense to the order whatsoever. It has not been sorted alphabetically. It hasn't been sorted from smallest to biggest. It hasn't been sorted from biggest to smallest. It's not in the same order that I wrote it. Yeah. Okay, so what this is called an unordered list. Or sorry, an unordered collection. Okay, it's an unordered collection because no matter what you put them in, there's no guarantee they're going to stay in that particular order. Okay, that's the first one up. Okay, so here we go. That's a bunch of colors. Yeah.
So if it's an unordered list, if you ran the thing again, would it come out in the same order or would it change orders every time?
Okay, that's a nice question. Usually what will happen is every time that I run it, you'll probably see exactly the same result. There is no guarantee that this will happen, okay. But most interpreters would always, okay, still you do that, most interpreters would always show you the same order, but you cannot predict what it's going to be. Okay, for example, okay, this interpreter is a bit different because it always runs in the browser. Okay, and it's always the same Python version that runs. But if you were to take this program and run it here, even at home, you'll probably see green, red, blue. But if you try another online interpreter, it might show up in different orders. Okay, and if you try like idle, it might show up in a different order. Might be the same, but there's no guarantee. That's the important, is there's no guarantee of the order. Okay, so that's the only thing. All right, so here we go. That's for colors. Here we can print a horizontal line. All right, let's have some numbers. Okay, 1, 2, 2, 3. Okay, so the first thing, will it show up as 1, 2, 2, 3? It might not. We have absolutely no idea. Okay, so here we go. And we know it's a set because of the curly braces. Oh, okay, yeah, that's going to become a problem here in a few minutes. All right, and if I print these out, let's take a look. Okay, yeah, something changed.
There's a missing number.
Yeah, there's a missing number. Why? Well,
It's
because it's repeated. So, one new rule about a set. So not only is it unordered, it's a collection of unique elements. Okay. In other words, if you put 2 2s or 5 2s, when you look inside the set, there will only be a single 2. Okay. So basically this is what we use. We use these if we want to get rid of duplicate stuff. All right. The same thing is true up here. If I were to toss in another red and another red and another red, you're only going to see one red. Okay, so if you try to stick extra things in. Slightly different format. I have to, no, sorry, don't want to say that one. Not yet. Sorry? Oh, what's the type? Okay, we just did that. Type of numbers. It's a set. Okay, yeah. Okay, it's the same as the previous one. Okay, all right, here we go, print. Okay, horizontal line, we'll leave that up. Okay, what else have I got? Okay, oh, I have a bunch of items, and I'm going to use exactly the same thing that I've got here. Okay, 5465132 65132 1332 6993 1022. It's the same examples that I have on the slide, so hey, you know what? I might as well use it. When I run this, okay, first of all, are there any duplicates?
1332.
Yeah, 1332. So when I run this, I should only see one of them. And is there any guarantee about any of the orders? And the answer is no. It's just going to come in some kind of a big long, who knows what. Okay, it's not important in the world. If you're a set, you don't care the order of things. You just care whether or not something is there. That's the only rule that we have when it comes to sets. Okay, so let's take a look at some of the things that we can do with these. Okay, so why use sets? The easiest thing is you use them to get rid of duplicates. Very, very important. Like, for example, at one point, before the current PeopleSoft system was in place for recording attendance, we used to still have the attendance taps here in the theater, and what I would get afterwards, I would get a list of which cards tapped and when. Okay, now, think about this. If somebody taps 5 times, or sorry, if somebody taps twice,
Yeah.
are they here? And the answer is, of course they are.
Yes.
All right, but you know, if you allowed for duplicates, maybe tapping once puts you in, tapping it twice sets you out. Oh, okay. So what I would end up doing is I would take everything and throw it into a set just to guarantee that there was only one of each. Yeah.
Can I use a bin function?
Yeah, okay. So we that's, I think, on the next slides. Okay, so what can we do? Okay, so why use sets? If you want to get rid of duplicates, it's a really great way. If you want to apply set operations, that's another really good way. We'll have to get that yet. And you can also determine whether or not something is in a set really, really quickly. Okay, we'll see examples of all of these. All right, so the first things up is, do we have those operations like for adding more things to a set? And the answer is, yeah, of course we do. Okay, so here we go. Students. Okay. The whole thing begins with, okay, 6006 1234. Okay, and here you go. This is not a trick question. Print students. Let's print the length of students, and let's print the type of student so we see what we've got. Okay, obviously the print students will be just the student itself with any duplicates removed. What is the length? What do you think? Yeah, it's 1. It's exactly it. And the type is a set. Okay, so 1 student inside a thing called set, and it's exactly 606 1234. Okay, now people are asking about append. Okay, students dot append. Okay, 60062222. Okay, run it. What do you think? No. Okay, unfortunately, it's not an append. Remember, if you think about what append does, append takes a number and adds it to the very end of a list. Well, that suggests that there's an end. Sets are unordered, which means that there's no guarantee of where the end is. So there's no concept of being able to put something in. So instead of using append, they had to use a different function because you want to make sure it's very clear that you're not tagging something onto the end. The good news is it's pretty easy. It's called add. Okay, so here you go. Now it's got 2. Okay, so it's add instead of append. Does it show up at the end? Yeah, it did this time, but you know, same deal. There's no guarantee of it.
Add is only used on sets?
But add's only used on sets, yeah. Okay, so it's like an append, but only for sets. And what happens if you come along, okay, here, we'll do a couple more. Students dot add 6006 3333 and students dot add 6006 1234. How many students will I have in my set when I am finished? 4. Okay, very good. That's 3. Why?
One of them.
Yeah, because one of them is duplicated. Okay, good. All right, and again, notice that the order is completely unpredictable. Nobody could have said, oh, it's going to show up, 6006 3333 is going to show up in the middle. You have no idea. Okay? All right, so that's how you add things. Okay, in that case, can we pull things out? Okay, well, that's reasonable. Okay, here we go. All right. Sorry, we're going to remove something first. Students dot, the operation is remove. Pop, remember the difference between a pop versus a revmo, okay, which we'll fix in a second. Lists had a remove, and they also had a pop. What was the difference between the remove versus the pop? Okay, the remove, you provide the value. The pop, you provide the position. There is no position, so no, pop isn't here, but remove is one. Okay. All right, so I can go and I can remove 60063333, and then I'm going to print students so you can see what it looks like. We're going to see it first with 3 students, then we're going to see it with the 2 students.
Yeah.
Okay, pretty straightforward. What if I remove 60063331?
Error.
Yeah, it's actually an error for the same reason that they used in the world of lists. If you want to know, you can't call remove unless you use in first. Okay, so for example, I could say something like this. If 60063331 is in the students, then you could try removing it this way. Okay, that'll be okay. Okay, but if something isn't there and you try to remove it, crashes. All right, because this sometimes happens where you don't want to have to constantly put in if statements. I mean, nobody likes to write if statements. I don't like writing if statements either. There's another word which looks a little bit weird. It's called discard. Okay, and what this does is this gets rid of an item,
Okay.
just like remove, but if the item isn't there, it doesn't crash. Okay, that's just, you have to keep these in mind. So if you're just trying to get rid of things and you don't want to check whether or not it's there, you can use discard. Use whichever one's appropriate at the time. Yeah.
So from a central use, it doesn't add nothing, right?
That's right, because append suggests that there's an order.
And it's only for lists.
It's only for lists, yes. How about a tuple?
No, you can't change it.
Because you can't change it, yeah. Oh, and by the way, sometimes I stick questions on the midterm. Okay. I posted something about the midterm format. When you switch from the MCQs into the programming questions, you get access to the interpreter. And I always include like a little, I call it a cheat sheet. It's like a list, it's a bunch of functions. In this case, you'll have access to the list functions. I'll share it with you so you know what's coming. But I can't just put it there. I always have to put some kind of a question.
Okay.
And sometimes what I do with the questions is I will put slightly challenging things like, can you append to a tuple?
No.
And if you want to, you'll have access to the interpreter and you can try it. Okay, so if you get something, you just make up a little test program. And sometimes I use this to find out, okay, does the student actually understand the words? Okay, so just to let you know, sometimes this can happen. All right, we got one more because it's on the slide. Here we go. It's called, spelled correctly, it's called clear. Okay, and what this does, gets rid of everything. There you go. Hey, that's weird.
Clear?
Yeah, take a look what happened, what I printed on line number 10. It showed up as set rather than curly brace. Okay, here's a bit of a weirdness. Okay, so here we go. This is like one of these unpleasant things. Okay, print type students. Okay, not a trick question. What type of students?
What type is
It's a set. Okay, what's the length of students?
one?
Okay, and then of course, obviously the students themselves. Very good. All right, and what type is students? Still a set. How many? What's the length of students? 2. Okay, and of course these things we have no idea about the about this, and it looks to me like absolutely nothing. So what are we expecting?
One?
Yeah, unfortunately, it's a dictionary. Oh, what's a dictionary? That's next week. Okay, it's not a set. Excuse me. Sorry. Unfortunately, a curly brace by itself is not a set. A curly brace with one value is a set, but a curly brace without is not. If you really want to have an empty set, you have to spell it this way. That's a set with no elements. Okay. It is, sorry, it's one of these things you get used to and you go, oh yeah, it's one of those things. Okay. And trust me, I've been burned a whole pile of times with it.
So the empty curly brackets is a dictionary.
Yeah.
Okay.
Okay, so we'll see that next week.
Okay.
Yeah. Okay. Okay, sorry, what are you asking? Is it an easy way to add the students? Okay, how about this? What if we ask the user to type in the student IDs, and we'll build up the set this way? Okay, that's reasonable. I can do this. Normally I'd stick this into a function, but I think we can do this. All right, let's have SID input, int input. What are we doing for time? I just want to make sure I don't run out. Sorry, I think this is going to be one of these classes I'm probably going to go right to the end. So not even a Kahoot. Ooh. All right, anyway, enter student ID. Is what I get for putting everything in one shot. Okay, well, SID does not equal to -1. Here's what I'm going to do. Sorry, we're going to copy all of this, paste it in here. I hope you recognize the format. It's a Sentinel-based loop. Okay, here's what I'm going to do. If people are giving me student IDs rather than -1, I'm going to go to students and I'm going to add whatever the person just typed in. Okay, there you go. So it's a building up. So student ID, I'll use short numbers. There you go. So there's a set with everything. Okay. Oh, can you sort a set? No, because sets have no order. But if somebody enters the same number twice, at least the duplicates will be gotten rid of. You can sort a list, but you can't sort a set. Okay, and I believe that we will show you in a few minutes how to convert between things. All right, set operations. Okay, once again, back to your think back to your math course. In your math course, you would have learned about A union B, A intersection B, and A minus B, set difference. Yeah, these are exactly the same types of operations. They're available within Python because they thought, okay, well, maybe you want to be able to solve certain types of problems. And I've got some problems coming up here. Okay, and then I'll actually show you a problem that I ended up solving earlier today. Okay, so here we go. I'll steal the code so I know how to write it. There we go. So there's a bunch of students enrolled in Comp 1001 and Comp 1002. Okay, yeah, and they kind of go off the edge. Sorry, should have been a touch smaller. You might be interested in knowing, okay, I need a list of all the students that are in these courses, but of course without duplicates. Okay, so here's the way how you deal with this. If you're dealing with this in math, you would have one set, A, which is the Comp 1001. You'd have a B, Comp 1002. And what you would do is you would merge those together using an operation called union. And what that would do is that would be all of the items from both sets, but of course there's no duplicates. So can we do this here? And the answer is yeah. All students would be simply equal to Comp 1001, that's the name of my set variable. And the way how you union, there's two ways to do it. That's one way, Comp 1002. Print all students. Okay, so that's a combination. So if there's anything that's being duplicated, like for example 60301111, I can see it in both places here, it will only show up once in the result. If you don't like to try and memorize the vertical bars, too bad, do it anyway for the test. But afterwards, if you can't remember these things, that's exactly the same thing. Okay, dot union.
How do you siphon the vertical bar on the keyboard?
You'll have to find it on your keyboard. It's usually a shift on the same key as the backslash. Okay, so this one right here, usually it's the shift version. Okay. All right, so both of those are completely fine. You better know both for the test because you never know what somebody's going to end up giving you. All right, there you go. That's the union. That would be if you say you needed to email everybody, but you only want to email them once. Okay, there's another one. Okay, think back again to the math course. Yeah, there's one called intersection. All right, does anybody remember what the intersection of two sets are for math? It's the things that are common between each other. So this wouldn't be all students, but this would be common students. There you go. Those are the students that are in common. Okay. All right. And if you don't like this format, there's another format. It's actually a little bit easier to remember. It's an ampersand, which kind of makes sense because it's this and this. Okay, all right, so that's not too bad. Yeah, there's another one as well. Okay, here, I won't bother running this one because I know I'm running short on time because I'd rather do something a little bit more. This is a difference. Okay, so what this would be students who, so if I find my cursor, it is students who are in Comp 1001, but I took away all the students who are in Comp 1002. So if I wanted to know who's taking 1001 but not 1002, this would be this. And it's pretty easy to remember. It's a dash, a minus sign. Okay, that's pretty decent. There's actually another one as well, which I haven't included. It's called a symmetric difference. It's it looks like a hat. You find it on shift 6. We don't use it that often, but it's for things that are in A or B, but not in both. Okay, you can actually calculate that other ways using math operations. Okay, iterating a set. Yeah, same thing. You can iterate through them. Set up a for loop and go through each item. You cannot, however, do this. So we better do one of these. Better do this as an example. Okay, so if I said for S in Comp 1001, okay, I'll use X for right now. There you go. Yeah, there you go. There's the values. There's no guarantee of order. Yes, it will probably always be the same order when you run it on the computer, but there's no guarantee which way is coming. All right, so just like a list and a tuple, except you won't be able to do something like this. You won't be able to say for index in range, length of Comp 1001, print Comp 1001 at position index. Okay, you're not going to be able to do this. Okay, let's take something really, really simple. Print Comp 1001 subscript 0. Yeah, you can't do it because remember, it's unordered. There's no guarantee where it is. So it just says that, sorry, it's not subscriptable because, well, sets have no order. Yeah. You can iterate through them using a for loop, but you can't iterate using indexing. Yeah. Okay, so you have to avoid that one. Okay, let's see what else we've got. Yeah, now we're making some progress. Okay, converting between a list, a tuple, and a set. Really, really trivial. I showed you already how to deal with a few of these things, but here you go. Somebody asked earlier about sorting a set. So here we go. Print Comp 1001. Print type Comp 1001. All right, not a trick question. What type is Comp 1001? Yeah, it's a set. Very good. All right. I'm just going to use some very strange looking variables just so we have these in place. All right. A is going to be equal to list Comp 1001 print type A print A. All right, what type is A? It's pretty easy to read, right? No, that's an error because I forgot to do this. Okay, here we go. Yes, it's a list, and notice that it is actually a list. Oh, what can you do with a list? Well, whatever you want. Somebody was asking earlier about sorting, and the answer is yeah, I can sort that once I get it back out. Okay, you can sort lists, but you can't sort a set. But you can easily take a set, turn it into a list, and then sort it. And what if I take the list and put it back into a set again? Well, then you lose the order. Okay, and to convert from a list back to a set, very easy as well. So you can say B is equal to set of A, and then print B. Oh, C is equal to a tuple of A, print C. Yeah, all we're doing is we're just switching things back and forth. We're going from tuples to sets to lists. The only thing that you have to watch out for is when you turn a list into a set, duplicates disappear. Okay, and that's useful actually. If you have a bunch of things and you need to get rid of the duplicates, you turn it into a set. If you take a set and turn it into a list, that's fine. There won't be duplicates because there wasn't in the first place, but there's no guarantee of the order. Okay, if you take it and put it into a tuple, well, it'll be the same order as the list. So at least it's kind of consistent. But of course, then you can't change it. But this is very nice. I mean, they've done a nice job at this. They're all very easy for putting things back and forth. The most useful one is converting something to a set to get rid of the duplicates. We use this all the time. In the, okay, midterm, maybe not, but the lab exam, there, I can almost guarantee you there's going to be at least one question that says, take this piece of information and make sure that there are no duplicates. That's how you do it. Of course, it won't be that obvious, but just look for things, distinct values, duplicate or non-duplicates, these types of words, almost always kind of suggesting that you want to use a set. So it's really useful for removing duplicates, making data immutable, turning it into a tuple, and changing something so that you can use it in a library. Okay, and we've seen this before. Sometimes you have something in one piece of data, one format, you need to change it somewhere else. Okay, what did I put in here? This is the example I had earlier. So remember, if I have a possibly dangerous function that I don't know what it does, I turn it into a tuple, and I'm guaranteed that data was not modified. Okay, and this can be really, really helpful. I've also got one final thing in here. Sorry, let's take 1 or 2 more minutes, and because this is actually really, really cool. There's a comment here in this very last page that says the sets are fast, with an exclamation mark. Okay, this is actually one of the things that sets are really, really good for. It's very quick to find out if something's in a set or not in a set. And I've got a small example on the next slide. Let me copy over the program so you can see what it looks like. We'll try running it. I'll have to take a couple minutes to explain what it is doing. Okay, it looks kind of intimidating, but trust me, it really isn't. Okay, you need to look at it. Okay, all right, everybody's seen random. Okay, time is used for telling what time it is. Okay, well, I'll show you how it's used. I've got a function called createList. What does it do? It makes a list, empty list. It goes through n things, and it appends a random number. So this is used for creating a big list of random numbers. All right, I got another function called createSet. What it does is it creates a set of random numbers. Now, obviously, there won't be duplicates. Okay, but it's still going to be a lot of random numbers. I've also got a function called findValue, and I said dx. So I'm looking for the value x in the collection called d. This is all I'm doing, and I'm just using in. All right, now let's look at the real program. Okay, first thing that I do is I create 10,000 random numbers, and I stick them in a list. Next line's commented out. Okay, we'll uncomment that in a bit. I start a timer, because that's how you measure things. If you want to find out how long something takes, you press start on your stopwatch. That's basically doing this right here. You press start, and I go in. Don't worry about the found or not found. This is just to make sure the optimizer doesn't cause problems. And I repeat 1 million times. I keep searching for a search value. I search for a random value inside the data. In fact, I don't even need to find value anymore. Okay, so what I'm doing is I'm searching 100,000 times. Okay, not that I'm trying to find something. I just want to find out how long does it take. So the question is, how long does it take to search 100,000 times in a list with the 10,000 items? Okay, that's what I'm really measuring here. And you might say, yeah, but nobody ever has that much. Yeah. How many items does Google have in its database? Yeah, okay, it's a big number, right? And how many times per second is that being accessed? A lot more than 10,000. It's a legit problem. Yeah. Okay, it really is a legit problem. All right, so the question, and then at the end, you just calculate how long did it take. You stop the stopwatch, you subtract the difference. It'll tell you how many seconds it took. All right, so let's go ahead and run this. I haven't checked this today, but I hope this runs okay. All right, so it's off and it's running. I'm printing every 10,000 just so that I know something's happening and my program hasn't hung. Okay, so once it finally stops, it will say elapsed time. Okay, so we know we're almost there. All right, 15.76 seconds. That's pretty good. I mean, think about this. Somebody searched 100,000 times in a list of 10,000 items and only took 15 seconds. You try that. Because how many elements could you look at in 15 seconds? Probably like 20 or 30. All right, this guy's looked at like, what do we got here? 100 million things. That's pretty good, right? All right, 15 seconds. It's a pretty fast computer. Let's go, and instead of putting the data in a list, I put it into a set. Now, I suppose I could have done it slightly differently, but in any case, I could have just said data is equal to set at data. All right, obviously, there's not going to be duplicates. So a couple of the values are going to disappear. Trust me, there's not going to be many duplicates in the first place. And my claim is going to be a little bit faster. All right, so would you be impressed if it was only 10 seconds to do it? Okay, that might be impressive. What about if it was only 1 second to do it? Does that sound impressive?
Yeah.
Okay, so that's obviously not going to happen, right? Okay, so you're right. It's not going to take that much time. That's how long it takes. 0.1 seconds. That's a little bit quicker, isn't it? Yeah, that's way quicker than a list ever was. It's doing the same amount of work. It just happens to be that finding things inside sets is really, really quick. So if you have a bunch of data and you want to be able to find things quickly, yeah, sets are actually the way to go. Does that mean that Google uses sets? No, they probably use something else called hash tables, which are kind of related to sets because, well, does Google allow for duplicates? Well, maybe they do, maybe they don't. All right, but there's the final thing is sometimes if you have problems, you can solve problems really, really quickly with these. All right, let me point out, okay, so no time for the coot because I know it'll take just a few minutes longer, so we'll squeeze it in. I've got one for nested list, but entertain me or be entertained by me, whichever way it is, for another couple of minutes, okay? And I will show you a problem that I was working on today, and I came up and I said, hey, I know how to solve this. I'll solve it using a set. Okay, here's the situation. We've got a bunch of grade books. We got a lot of grade books. In this course alone, we've got, I think it's 15 grade books. Okay, one of the things that's really important is they all have to look the same. Like identical, they have to look the same. Sometimes we end up with 30 or 40. If you think about a COM 1010 course, there's like 70 sections of that, which means that there are 70 grade books. All right, so here we go. I'm just gonna call this grade book 1 for lack of any other thing to call it. And here is the problem that I had. And I decided to store everything into a set. In fact, it was a set of tuples, which you are allowed to have. Okay, for example, you know, maybe in a course you might have a quiz worth 30%. You might have a midterm worth, okay, we'll say 30%, and you might have a final exam. Sorry, I'm putting colons in here, wrong place, just commas for right now. That's actually what I was using. All right, and the final exam would have to be 30, okay, 40%. Okay, there you go. And, okay, just because we're here, we'll check it. Grade book 1. All right, there we go. There's the first grade book. All right. Now, the thing is that what I wanted to be able to do is I wanted to be able to pull out 2 grade books out of D2L and find out, are they exactly the same or not? Okay, and I'm going to ask you a question. Are those 2 grade books the same? Yes, okay. So what I was trying to do, of course, is I don't have 2 grade books with 3 items. I've got like a lot more. And I thought, you know what? Here's what I'm going to do. I'm going to look at what happens when I create the union. Grade book 1, union, grade book 2. Print UN. Now, see what I get when they match? I get exactly the same things. Okay, they're exactly the same. It's the same as the other 2. But watch what happens. You see, if one instructor decides that they're going to make this 45 and they're going to make the midterm 25, when I run this, I'm not getting the same thing. And I thought, hey, that's exactly what I'm looking for. In fact, what I could also do, just to make sure that everything was there, I also came up with the intersection, which I can't use that. I'll have to call it INS because IN's used for something else. Grade book 1 intersection, grade book 2. So UN looks like that, INS looks like this. If I end up with an intersection, the intersection should also look exactly the same. Okay, and of course there's another one called a symmetric difference, which I showed you, but we didn't have the chance to run. It's this symbol right here, grade book 2. Yeah, I see. I'll fix that one in a second. Okay, SD, thank you. There we go. The symmetric difference would show me all the differences between the 2. Okay, if everything matches, life is much easier because basically everything matches and the symmetric difference is empty. That's really what I was looking for. And you might say, well, hang on, I mean, you didn't really need to write a program to do this. Okay, give me 1 second. Okay, unfortunately I won't be able to run it. I can only pick up the values because Some weird problems here with my screens. Let me show you what the grade books actually look like, okay? And then say, would you want to do this by hand? So it wasn't 3 things. I have to copy the right one. Okay, here we go. Copy. There you go. That's what it looked like. Oh, okay. We have to format it so we can see it.
Yeah.
There. Over here. Okay, I better make this a little bit smaller. Okay, so you can see. No, wrong place. Here we go. All right, so there you go. There's what a grade book looks like. Okay, would you want to do that by hand?
No.
Okay, now repeat this 2,400 times across the entire university. Yeah, this is not what you want to do.
Yeah.
Okay, so here you go. Again, just so I can show you that, yes, it isn't just, hey, it's one of these weird little things. No, they really do have uses. Let me show you some of the code. Okay. I know, again, there's going to be a few things that you won't quite understand here, but, you know, by the end of the semester, you might. Okay, like, for example, what we already learned, that's a dictionary. Okay, I did this for something different. Take a look at this. You see, I've got a union, an intersection, and a symmetric difference. What am I doing? Well, I'm basically calculating the union and the intersection each time. Okay, and then what I'm doing is I'm doing a bunch of stuff here, but eventually I print these things out, and yeah, what I'm doing is I'm looking for the things that are in common, things that are in difference. And things that are in difference get printed out so I can say, hey, look, section number 1 has got a grade weight for the final exam is 35%. That's not allowed. It's different than all the others. So if you say that, oh, it's just a theoretical thing, no, this is a real life problem. Okay, so, and yeah, it was like, hey, you know what? I think sets would work really well. And no, it isn't just because I had to cover sets today. Okay, now, this is what I did. I actually figured I had to teach the course today until like a few minutes before class. I was hoping it would just go away. All right, so there you go. There is the, I think that's the final slide. Okay, that's the final slide. In case you want to try running the program on your own to see how much faster it is on your computer, and then it's just a little quick matrix to show what you'd use it for. If you need something to be ordered, you can either use lists or tuples. If you want to have things that are mutable, sets and lists could work. If you want duplicates, then a list and tuple is okay, but obviously not a set. And if you want to be able to index things, then you don't use sets. Really, sets are useful for one thing, and that is you don't want duplicates.
Yeah.
That's really what they're used for. Or you have some really fast stuff that you have to do, or you have some really cool math properties and you're trying to exploit it because it'll solve your problem. I could solve that same problem without sets, but it would have taken a lot more work. Okay, so you use whatever is convenient at the time. All right, so that's it. Just a final thing to remind you, okay, again, before you take off. Over here, so not the syllabus, but over here in the course home, just to let you know how this is going. Okay, midterm exam, just a reminder, it is on October 25th. I'm really sorry, it's a Saturday. It is early. Normally I'd make it a bit later, but somebody else booked the 10 o'clock slot or the 11 o'clock slot, so I couldn't do it because we need like almost all the rooms. You'll have 2 hours to do the test. I will send around a news item with the list of rooms just before. I don't want to put it in now in case I have to change anything. The format will be as follows. You'll have 12 multiple choice questions worth 25 points in total. So 2 points something each. No, some questions I only make 1 point, some questions I make 2, some I make 3. Things that are really review from INFS 1101, I only make 1 point. There's not many of those. Most are 2 points. There might be might be 1 3-point question. Something that's a little bit more challenging. Sometimes I'll add that. There will be 2 programming questions. We've been doing this for the past few semesters. It's working well. So in terms of time, it shouldn't be an issue. I always include one, what I call standard question, very straightforward type question. This should not be any real big challenge if you know how to solve the problems. Look, I can tell you already, it's going to be a function. Guaranteed, there will be a function. It will definitely use lists. Okay, it'll definitely use lists. Will it use sets? No, not quite. Okay, we'll get to that in a second. It won't be sets, but it could be lists, could be nested lists. Maybe, maybe not. But there's always one standard question. We work it this way that if somebody can't get the program to work, there's always some points associated with correct logic. Okay, not the full thing, but there might be like 5 to 8 points. I can't tell you what the number is. I have to look at the rubric again. All right, so if everything goes really bad, but you kind of had to start it, you may get a few extra points out of this. So it isn't an all or nothing. There will also be one challenging question worth 5 marks, and this is for trying to differentiate people who have B's and A's, because what I've noticed before is suddenly I'd have everybody with an A or everybody with an F, and I don't want that. I mean, having the standard question a little bit easier on the grading, that has helped to deal with the F problem, but I need something to distinguish between the A's and the B's. So I provide a fairly challenging problem, and if you can't get it to work, basically you don't get any points for it. Okay, yeah, it's kind of harsh marking, but it's basically all or nothing. But that's why it's only worth 5 marks. Okay. All right, so that's how this goes. Obviously, and return a result, that's fine. Topics, okay, so everything in the course until lists, so basic programming, decision structures, ifs, whiles, and so on, strings, looping functions, list, and nested lists, okay? We have covered tuples and sets. They're not part of it. We're also going to start on dictionaries, I think, before. Also not part of it. Okay, so don't worry about that. The week of the exam, we will do a review. The full week before the 2 lectures, I will come in, I will bring in previous copies of previous exams. We'll solve them together. Maybe not all of them, but we'll do some of them because obviously it takes me a bunch of time to explain things. So we might not be able to get all of it, but we'll bring in some sample questions about what's happened before. Okay, so all of this includes the slides up until, but not including today. Today is lecture 11. We have exercise sets 1 through 6, which are going to be the lists, including next week. The labs 1 through 4, and quiz number 1 and quiz number 2. Okay, that's what we're covering. So during the test, you will start off, you'll be thrown into, wow, I'm way over time. Sorry about this. You'll be thrown into an MCQ page where you'll have all the MCQs on one page. Okay, it's always the format like you've seen with my little Kahoots. What's the output of this program? When you click and you go to the next page, you cannot return back. When you go to the next page, that's the programming page. With the programming page, you get an interpreter. Obviously, I can't give you an interpreter while you're solving tracing questions because you just copy and paste and type. That's not this type of a test, sorry. So don't open up the test and go, next, because then you can't answer any of the MCQs. Okay, so just wait. There will be a timer shown. The timer is for the full time of the test, not just the MCQ parts. A bunch of people complained before, so I have to make sure it's very, very clear. It's not just the MCQs. That timer's for the full time, so 2 hours. You can decide when you want to switch. What can you bring? You can bring a pen and pencil with you if you want. I'll bring them anyway. But no, there's no cheat sheets. There's no calculators. I'll enable the built-in calculator within D2L. You've seen this before. Yeah, you really don't need to bring anything. And no, it's not a course where we bring in stuff for reference and so on. The reference sheet will be provided. I'll make sure that you know exactly where it is. Okay, and I'll show you what it looks like in advance. We'll probably set up even a small practice test so you can try to see what it looks like. Yeah. Sorry? Yeah, the evaluated labs 1 through 4. Those are those lab exercises where you're asked the right programs. Okay, you guys remember in the labs we have quizzes, but we also have things called labs. It's the labs, the programming exercises. Okay, all right, sorry, I'm way over, so I better stop.